Hello, I'm Professor Rad, and today we're going to talk about the greatest common factor, or the GCF. In our last video, we talked about how you could find factors of numbers, and today we're basically going to be comparing the factors of two numbers against each other and trying to find the biggest one that they have in common. So let's start out with a definition, and then we'll dig into an example. Definition 2 says if two numbers have the same factor, then that factor is called a common factor. Of those two numbers. The largest common factor shared between two numbers is called the greatest common factor. And we often abbreviate greatest common factor with GCF. Right? We've talked about mathematicians and their liking to abbreviate stuff and use shortcuts. So we'll probably refer to this as GCF very often. So let's get some practice in by finding the common factors of each pair of numbers. Now I'm going to go through part A and write down a little bit more so I can see my progress when I use this to study later. And then for parts B and C, I'll probably show a little bit less work on paper, just because we'll have been familiar with the process. So for part A, what I'm going to do is I'm going to find all the factors of 24. So I'm going to bring my calculator over here to help me out. And I'm going to do, as a reminder, 24 divided by 1. And I get 24. And then I'm going to divide by 2. And I get 12. And I'm going to keep doing this until the number on the right becomes smaller than the number I divided by. So we'll try 24 divided by 3. I get 8. Divide by 4. I get 6. And now here I get 4.8. Okay, so now the number I got on the right is smaller than what I divided by, so I'm done making my list. And anytime I got a whole number, that is both the number I divided by and the answer are factors. So for example, since I got a whole number here, that means that 1 and 24 are factors. When I divided by 2, I got a whole number, so 2 and 12 are factors. When I divided by 3, I got 8. And by 4, I got 6. And by 5, here I got a decimal, so that means 5 is not a factor. So I'm going to write over here on the left, I think, for part A. I'm going to list out my factors of 24, and I'm going to list them in order, so it's a little bit easier for me to check them later. So the order is really nice because when you follow this method, you go down the numbers you divided and then up the numbers you got. So we have 1, 2, 3, 4, 6, 8, 12, 24. And that means they'll all be in order. So for 24, we got 1, 2, 3, 4, 6, 8, 12, and 24. Oops, I'm not on B yet. Now I've got to find the factors for 26. So I've got to find the factors for 26. And I'm going to use the same method. So I'm going to do 26 divided by 1, and that should give me 26. 26 divided by 2 is 13. Divide by 3. 8.6 repeating. Divide by 4, and I get 6.5. So I'm still getting bigger numbers than what I'm dividing by, so I'm going to keep going. 5.2. Okay, still bigger than what I divided by, so we'll go another one. 4.3 repeating. So now I am smaller than what I divided by, so I can stop. And I want all of the whole numbers that I got on the right-hand side, none of the decimals. and their partners here. So it looks like my factors for 26 are going to be 1 and 2, 13 and 26. Whew! So we haven't even done the common factors part yet. We've just found the factors of these numbers. Now that we found the factors, we're going to circle all of the ones that show up in both of our lists. So for example, 1 is here in both lists, as is 2. Now since this one is shorter list, I'm going to use this one as my comparison. So 13 doesn't show up here, and 26 doesn't show up either. So my answer to part A is 1 and 2. Those are the only common factors, the only factors that 24 and 26 have in common. Okay, but Professor Rad, you might be wondering, do I really have to write all of this down? No, you don't have to. So I'm going to work through part B, showing some more minimal work. So for part B, we are looking for the common factors of 20 and 36. So we start out with 20 and 36. So grab my calculator to help me out. And I'm going to do 20 divided by 1, and I get 20. So what I'm going to do, because I know that on my list here I went down and then up, to account for that, I'm going to put 1 over here, and I'm going to put 20 off to the side. And I'm going to hope I left myself enough space. So then let's try 20 divided by 2. Okay, that gave me 10. So I'm going to have a 2 and a 10. 20 divided by 3, that's a decimal, don't need it. 20 divided by 4 gave me 5. And now, let's see, I got an answer that's bigger than what I divided by. Oops. But notice, I got an answer that's bigger than what I divided by, but the next number I would try to divide by is 5, and it's already on our list. So we're done checking for 20. Let's try for 36. So 36 divided by 1 is 36. I have a feeling this one's going to be big. Have a lot of factors. 36 divided by 2 is 18. So those are good. 36 divided by 3 is 12. So I've got 3 and 12. 36 divided by 4 is 9. I guess I wasn't wrong, huh? Don't have much room left. 36 divided by 5 is a decimal, and I'm still bigger than what I divided by. 36 divided by 6 gives me 6, and I only write it once because I only have to state it once in my list. And then 36 divided by 7 is both a decimal and smaller than what I divided by, so I can stop checking. All right, so my common factors, now that I've got my factors all listed out, I've got 1s in common and 2. I'm going to go across the top list because it's shorter than the second one. So the next one to check is 4. 5 isn't there. 10, 20. Okay. So this time we have 3 common factors, a 1, a 2, and a 4. Okay, and now for part C, I'm going to write down even less work, okay? So what I'm going to do for part C, we're looking for common factors of 15 and 28. Again, in this process, I'm doing the same amount of work. I'm just writing less of it as I become more familiar with the process. You want to make sure that you are leaving your future self enough hints so that you know how you find your answers. So if you can remember the process, then you don't have to write too much. But if you, like me, tend to forget things until you do them over and over and over and over again, then you might want to write some little tracks for yourself so you can follow along. So what I'm going to do here is I'm going to divide both 15 and 28 by 1. 15 divided by 1 is 15, and 28 divided by 1 is 28. So when I divided both numbers by 1, I got a whole number back. So that means 1 is going to be a common factor of them both. Now let's try 2. 15 divided by 2, oh, it doesn't work. So since 2 didn't work with 15, I'm not going to check it because I only want ones they have in common. So let's try 3. 15 divided by 3 worked because I got a whole number. So now let's try 28. 28 divided by 3 gave me a decimal. So although 3 worked with 15, it didn't work with 28. So I can't list it as a common factor. All right, let's try 4. So 15 divided by 4 gives me a decimal. And notice this decimal I got is smaller than 4. So that means this is where I'm going to stop checking my factors for 15. I don't have to check anymore. So that looks like the only factor 15 and 28 had in common was 1. Okay, so now let's take a look at finding what's called the greatest common factor. All right, so we're going to find the greatest common factor, or the biggest factor that's common for each pair of numbers. So for example A, we're going to compare 20 and 36. And we actually already started the work for that. In the last example, we found all of the common factors for 20 and 36. So to find the GCF, or greatest common factor, we just take the largest. So the largest among them was 4. Similarly, with 15 and 28, we found that the only factor they had in common was 1. So the GCF of 15 and 28 is going to be 1. Now, we didn't look at 51 and 34 before, so let's take a look at those. So in order to find the greatest common factor, we have to find the list of all of the factors that they have in common. Now, personally, when I go through this process, I kind of like showing my work the way we did for part B of the last example, where I'm not writing out everything, but I'm also writing out more than just the common factors. So that's the method I'm going to use here, but you do what works best for you. So I'm going to write all of the factors of 51. So we're going to do 51 divided by 1, and we get 51. I don't know how long this list is going to be, so let's just give us lots of space, just in case. Okay, so next, we're going to do 51 divided by 2, and that gave me a decimal, so no dice there. 51 divided by 3 is 17. So we have 3 and 17. 51 divided by 4 gave me a decimal. 51 divided by 5, decimal. 6, decimal, but I'm getting close to passing point. Another decimal. Okay, and now I've got a decimal and I passed where I needed to check. So I wasn't sure how many factors 51 was going to have, but turns out not too many, just those 4. That's okay. Let's try 34. So 34 divided by 1 is 34. And I don't want to keep moving the calculator, so let's put it there. 34 divided by 2 is 17. 34 divided by 3 is 11, so 3 is not a factor. 34 divided by, 4, don't want to skip it. Okay, that's a decimal, so 4 doesn't work. Neither does 5, and neither does 6. And I can stop checking for 34 now because I got a number that's smaller than what I divided by. So if I look at my common factors, they have 1 in common, and they have 17 in common. and that's it. So the biggest of those common factors is 17. And there we go. So I've got a few problems for you to try out on your own. List all the common factors for each pair in A, B, and C, and then you're going to find the greatest common factor for each of those numbers in D, E, and F. In the next video, we're going to talk about a few ways that you can do division a little bit more easily, or kind of check to see if a number is going to work. It's kind of an optional technique, but we're also going to talk about prime numbers versus composite numbers, and that's an important concept, so you don't want to skip that one. All right, I'm looking forward to seeing you in the next one, and have a magnificent day.